Hey guys, welcome to the Introduction to Cloud Computing video. Cloud computing has been at the forefront of technological advancements for the last decade, and also it has revolutionized the way companies used servers. So in this particular session, we'll be looking into the fundamental concepts of cloud computing, starting from what is cloud computing, the benefits and use cases, and also the future of cloud computing. Then we'll be looking into the deployment and also the various types of service models. So before moving on with this particular video, make sure you subscribe to our channel and also leave a like if you enjoy our content. And also leave a comment down below if you have any queries and we would be addressing them all. Now let's get started. So what is cloud computing? So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So to put it even simply, so it's basically you're getting resources, especially IT resources over the internet, and you only pay for what you have used. For example, a very simple one, which is Google Drive, you're going to pay per GB, you're going to pay for the storage. You're not paying for the application itself. You're not paying for the code itself. You're only paying for the storage you're using up. You're not paying for the application. So basically you're paying for what you are using, and that is one form of cloud services. So we'll be looking into the different types of cloud services. I'm just giving you an example of one type of cloud service, but essentially the IT companies started using cloud services which help them scale up and scale down, which helps them to host their applications, which helps them to deploy complete data pipelines on the cloud without any hassle. So those are infrastructure services. Again, we'll be getting to that, but these are some of the examples, and the IT industry was revolutionized once the cloud providers came out. Okay, so also instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases. So basically, instead of the companies buying data centers and setting up a complete physical data center by buying all the hardware, hiring professionals, hiring security and network professionals, which will obviously cost a lot, they don't have to put in any capital. They just have to select the cloud vendor they are going to use and directly use the services they are going to provide. So if you look at this image, so you can see cloud computing. So using a cloud computing provider, like let's say AWS or Azure, they provide you services such as networking services, and they provide you software applications, security services, data storage, BI services. So you can also basically deploy your BI applications, your software applications on the cloud, and you can basically have one central portal from where you can access all of this. So that's exactly what cloud computing is providing to you. All right. So on-premises versus cloud computing. So on-premises is more of the thing which we are talking about, that is a company's own data center. They have their own data center where they have their own physical hardware, where they have to set up and configure everything. They have to hire professionals in order to basically maintain and upgrade them every single day. So for that, if you can see to the left side of this particular image, so customization and implementation, the hardware, the IT personnel who are required, the maintenance, the training for new personnel who are coming in. And so basically the ongoing costs are a lot. For example, when there is a downtime, let's say when your data center goes down, when there is a power outage, rewriting integrations, customizations. If there are applications which are dependent on other dependencies, then in that case, you'll have to upgrade them every single time when the dependency is also updated. And then the maintaining of hardware, whenever a new set of hardware comes out, you have to upgrade and maintain your network and your security so that there is no breaches, so that there are no unauthorized person who are trying to get into your data center. And basically it will cost a lot. So these are the ongoing costs in an on-premise data center. But when it comes to cloud computing, so ongoing costs are the subscription fee. Okay, so basically you put in the money on the subscription fee because everything is already set up by the cloud service provided for you, and you just have to pay the subscription fee to use it. And the implementation, customization, and training. So basically you'll have to train your employees on the cloud service, or they should be already trained in it before you hire them. There are certifications which we can take and get accustomed to that particular cloud provider. And then implementation and customization is again will be done by those cloud professionals. So to put it very simply, cloud computing is a lot cheaper than setting up a complete data center because obviously you have to do a lot of work and also put in a lot of capital investment upfront. In cloud, there is no upfront cost. You just pay the subscription fee and you pay as you go. That is every single month you pay it as a bill. All right. The top cloud service providers. So we were talking about cloud computing service providers, right? The subscription fee. So the top three ones are AWS, Azure, and GCP. So AWS is owned by Amazon. They started in 2006. They started off with two services, EC2 and S3, and they basically changed the way IT companies started using servers. And then came Azure in 2010. Google Cloud launched in 2011. So, and then these guys have been at the forefront of cloud advancements, and they are the top three cloud providers in the world even at the moment. Okay, so the next thing we're going to look into is the cloud deployment models and the cloud different types of cloud services. So the three models are basically public cloud, private cloud, and hybrid cloud. So the public cloud, these basically are owned and operated by a third-party service provider while delivering their computing resources like servers and storage over the internet. So public cloud, to be very simple, so these three are all public clouds. So they are a third-party cloud vendor who provide you resources over the internet, which you are accessing it through the portal, and you're going to pay them at the end of the month for whatever services you have used. So these are public cloud service providers. Also, private cloud also can be given by AWS or Azure or Google Cloud. But again, a private cloud is basically cloud computing resources used exclusively by a single business. When it comes to public cloud, let's say there is a data center. That data center, let's say there are 100 customers and 100 customers are using this particular cloud provider. So that data center will have the servers, the storage, the other services of all those customers running in that one data center. So it's not exclusive for one particular customer, but so other customers can't access the resources, even though in one physical hardware there can be many servers running which can be of various customers. But when it comes to private cloud, you will be provided dedicated hardware. Even though it's not your hardware, you are renting it, but you will be provided dedicated hardware. Let's say you have been dedicated 10 servers, so in those 10 servers only your company's servers and your company's resources can run. Also, a private cloud can be physically located on the company's on-site data center. Also, one more thing, in this case, a private cloud can also be set up by a public cloud provider like AWS or Azure. You can also basically purchase a private cloud subscription from them, which will give you basically a dedicated hardware, and nobody else can basically run their resources on those particular set of hardwares. It will be exclusively given to your business. And finally comes the hybrid cloud. Hybrid clouds combine the power of the public and the private clouds, bound together by technologies that allows data and applications to be shared between them. This is again pretty simple. Let's say your company wants to have an application. So the application's front end, the mission critical data, not the mission critical data and the mission critical code. So they just want to put the front end of the application in the cloud, in the public cloud, which is internet facing. People should be able to see your website, right? And then they want to put the database, which is the data, mission critical data, and the code, which is really essential for the application to work, in their own on-premises data center, that is their private cloud, so that the data is not stolen or their code is not stolen. Okay, so now the public cloud has the front end running and the private cloud has the back end and the database running. So in this case, there should be a connection between these two. So normally, if you want to make those connections, if you're separately using a public and a private cloud, you will have to use a VPN tunneling, or create a peering network. So that will take some time. Instead, you can just use a hybrid cloud model, which will combine the power of both, so that you can keep whatever you want in the public cloud, and very mission critical and sensitive data and information can be kept in the on-premises data center. And many companies also use this particular cloud computing model, which is really essential. Okay, so these are the three different types of models, guys. Now let's move on to the next topic, which is the cloud computing services, the different types of cloud computing services. So software as a service, platform as a service, and infrastructure as a service. So software as a service, I already gave you an example at the beginning, which is Google Drive. So Gmail, Google Drive, all of these are software as a service. You may ask why? Because they are providing you a software over the internet. you're not doing anything, right? You're not going to code that application. You're provided the software over the internet. You're able to use the software over the internet using any device. And that application's code can be running on any remote server. That application's data can be stored on any remote server. The software is running on a remote server and you are getting that software. It's not running on your local desktop. So Gmail, if you open mail.google.com, it opens up the Gmail website, the Gmail application. So you do not know where that particular thing is running, but you're given that application, you're given that software as a service so that you can use it over the internet. So that's basically software as a service. Next comes platform as a service. In this case, application development and deployment. So basically, platform as a service, they'll give you a platform in which you can, let's say there is a platform called Elastic Beanstalk in AWS where you can upload your code and it will automatically host the website for you. For example, let's say you have a Python application and you want to host that Python application. So in this case, if it is a regular one, then you'll have to launch a server, and then in the server you'll have to install all the softwares and upload all the dependencies and then deploy your application in that particular server to make it run. But if you do not want to do that, if you just want to concentrate on the code and you want to make your application better and secure enough, and you do not want to worry about the server and the infrastructure part, in that case you can go with a platform as a service, in which case basically you just select the platform, for example Python, and then upload your code and it will automatically host your website and deploy your complete application for you, and you don't have to do anything else. You just have to concentrate on the code and make sure it is compatible with the platform you're uploading or deploying it to. Okay. Next comes infrastructure as a service. So in this case, servers, storage, operating systems, database engines, any kind of infrastructure you're getting over the internet is infrastructure as a service. For example, you can launch a server and you can start basically upgrading your server. You can start installing whatever software you want in that particular server. You can basically use it like your own computer, and then you can basically terminate it whenever you want to. It's not like once you start a server, it should be running for a certain period of time. You cannot terminate or delete it. It's not that case. Let's say you want to use the server just for 3 minutes, you can do that over the cloud provider. So the main difference between a platform as a service and the infrastructure as a service is the control you get over what you're going to do. In platform as a service, you only get the control over the application which you are building. You're just deploying the code and the cloud provider will make sure to launch a server and host your application inside of it. You're not going to be given access to the operating system level. But when it comes to infrastructure as a service, you will be given software and operating system level control so that you can install and upgrade your server according to your needs. It's more of, you can configure it more. If you just want to host your application, in that case, go with a platform as a service. If you want to configure your server in order to make sure that every single part of your application is working and it's properly deployed, then you can go with an infrastructure as a service method. But it's not just servers, even storage. For example, there is something called S3 in AWS, there is blob storage in Azure. So all of these are infrastructure as a services where you're given storage over the internet, where you're given servers over the internet, where you're given database engines over the internet. Okay, so these three are the main services, these three are the main cloud computing services. And so at the beginning, learning these three are more than enough. All right. Okay, so to give you a more understanding about these services, I'll just brief about these on this particular image. So on-premises is completely managed by you. So every single part, every single aspect of the on-premises data center is managed by the company itself. So the applications which you are deploying on it, the runtime, the middleware, the operating system, the virtualization of the servers, the storage and networking, everything is managed by the on-premises, the company. Okay, and then there is infrastructure as a service. So in this case, if you see over here, the applications, the data, the runtime, the middleware, and the operating system is managed by you. Okay, so because you are creating the application and you are uploading the application and the data which the application generates And the runtime, for example, the runtime is basically, let's say you create a server and you're installing Python inside of it, and so that you can deploy your Python application. So it's a Python runtime, so that is maintained by you. You can upgrade it or downgrade it according to your need. The middleware is what makes the application run, the middleware, the logic, and the softwares you're using for it. And the operating system, it could be Windows, it could be Linux, it could be any Linux distribution, or it could be Mac. So all of this would be managed by you. And the virtualization, the deployment and provisioning of servers, the provisioning of storage, the management of networks, everything will be managed by the cloud vendor, AWS, Azure, or GCP, whoever you're using. Coming to platform as a service, so everything except the application and the data is managed by the vendor. As I told you while explaining in the previous slide, it basically makes sure that it creates the servers, it creates the runtime, everything for you, and it is already set up, and your application will be directly deployed into the existing setup which it created for you. So everything else is managed by the vendor except the application you've created and the data generated by the application. And finally, software as a service, as I told you, let's say Gmail, you don't own anything, everything is managed by the vendor, you don't have to manage anything, you just use the application. So that is software as a service. All right, so now moving on to the next topic, which is benefits and use cases. So first, let's just understand the benefits of cloud computing. So we've seen the cloud computing models, we've seen the cloud computing services. From that, you could understand what kinds of benefits cloud computing provides. So to just summarize and brief that, I've created this slide. So first of all, reduced IT costs. So the first thing any company wants to do is basically try to reduce their operations and IT costs, right? So that's exactly why they are trying to shift from an on-premises data center to cloud computing, so that they could cut costs and make it even more profitable. So in this case, they could easily reduce IT costs because their on-premises data center, they have to pay for the IT and the networking and the security professionals. They have to pay for the hardware. Let's say if some hardware is broken, they have to maintain and repair it, they have to upgrade it, and they have to pay for that. So there are so many hidden costs as well in running a data center. If there is a downtime for 1 hour in the data center, that will again cost them. So all of this will eventually lead to very high operation costs. But when it comes to cloud computing, you're not doing any of that. You're only paying the subscription fee, and everything else is managed by the cloud provider for you, which will significantly reduce the IT costs. You'll only have to pay for the services and the resources you're using on the cloud provider. All right. Next comes scalability. So this is really important. When it's an on-premises data center, let's say you have 1,000 users, and your application could handle 1,000 users at a time. And let's say your application has 10 servers in your on-premises data center. So now let's say each server can handle 100 users. So in this case, your application could handle 1,000 users. And let's say your application has become viral overnight, and there are 10,000 users using your application right now. So in that case, if you have only 10 servers running, it cannot accommodate all the 10,000 users. It could accommodate only the 1,000 users, which will be a significant loss for you. So in this case, if it is an on-premise data center, and if you only have 10 servers running or 10 servers available at the moment, you cannot do anything else. You can basically buy more servers and configure it and upgrade it and set it up. But again, that will take a lot of time, and that will also you'll have to put in a lot of capital to do that. But when it comes to cloud computing, let's say 10 servers are running, you can set up a policy which will check the traffic, which will check the CPU utilization of these servers. If they are utilized completely, it will automatically launch more servers in order to accommodate the incoming users. So let's say there are 10,000 users, and so 1,000 users can be handled using 10 servers. So now there would be 90 more servers created so that it could handle the incoming 10,000 users at that particular point of time. So let's say after some time, it's basically after midnight and people are logging out of your application. So now there are 5,000 users, there are not 10,000 users. When it again in cloud computing, so it will automatically notice the reduction in the CPU utilization in the servers, and it will automatically reduce 100 servers into 50 servers, which could handle 5,000 users. Okay, I think I'm pretty clear in the scalability part. You can scale the number of servers up or down according to the needs. You don't have to basically have to keep running certain number of servers all the time, which will cost you more. You can cost optimize your servers using basically scaling options. And then global infrastructure, let's say you have your application in India and you want to globally make it available. Let's say you have a customer base in US as well. If it is not in on-premise, then you will have to get a space in US and you will have to set up the complete data center all over again. But if it is cloud, they have an established global network all around the world, and you just have to deploy your application. You'll just have to duplicate your application into the US data centers, and that is more than enough for you to make sure the application is going to be available for your US customer base. And then up to date, so up to date is basically, again, they make sure it's updated, the hardware, the software, everything is updated. And one more point in up to date is that, so whenever there is a new groundbreaking AI application or an ML application is available on the so basically when it's coming out, so the first people who are going to adapt it are the cloud service providers, because they want to provide the latest innovations to the customers, basically either to retain them and to show them that they are constantly improving, because that will help their business model. So whenever there is a new technological advancement coming in, the cloud providers are going to adapt it and going to provide it to you. So you don't have to do any other work. They'll already create a service for you and provide it to you. You will just have to use it. And then finally, reliable data backup and disaster recovery. They already have failovers set up in cloud service providers. You will just have to use those data backup services. You'll just have to use those data disaster recovery services in order to make sure your application is running all the time without any crash. So that is, let's say your application is running in one data center, and let's say there is a power outage in that complete area. So if you have not duplicated it into another data center, in that case your application will be down until the data center comes back up. But if you have a disaster recovery failover setup and you have a standby application running in another data center, so whenever one data center fails and your application is not running in that, the standby application will automatically start running, and the incoming customers will be redirected to the application which is running on that particular data center, which is a different one. All right. So this can be done very easily using cloud computing. So these are some of the benefits. There are even more benefits in cloud computing. And then some use cases, big data analytics, video streaming platforms, for example, YouTube. So YouTube is one big example of cloud computing. And then also Netflix. So Netflix entire architecture. So Netflix went all in AWS. That basically means everything they use, that is the storage, that's the servers, the database engines, the data warehousing tools, the analytical tools, everything is running on AWS. Netflix completely went on AWS, and you can know how fast Netflix is if you have used it. And Netflix is also pretty lightweight, and also it is the biggest video streaming platform in the world, the premium video streaming platform. YouTube is the biggest video streaming platform, but with a premium there is a paid streaming platform. Netflix is the biggest one, and in this case they went all in AWS, and you can basically shows how big cloud computing is and how major impacts it's going to make in the upcoming future. And the disaster recovery, we already discussed it. Serverless computing, so you don't have to worry about the servers. You can just upload your code and deploy your applications without even having to provision servers by yourself. Again, we discussed it in platform as a service. And then AI and ML as a service. So this is one important thing which right now it is making strides in the IT industry. So cloud providers already have this ML ops setup. So ML ops is basically machine learning and operations, where you can create a complete machine learning pipeline using the cloud itself. You don't have to set up anything specifically. You can use the inbuilt services in cloud. For example, if you talk about Azure, there is a service called Azure Machine Learning, which will help you set up a complete machine learning operations pipeline. And again, when it comes to AWS, even they have EMR, they have code pipeline, they have their own operations and DevOps setup, which you can use directly in order to deploy your machine learning or artificial intelligence models onto the cloud computing providers. Okay, so again, these are some of the use cases. The cloud computing is used in so many different industries, and these are some of the examples which I'm giving you, because these are some major industries, and these are some of the major use cases which cloud computing is used for right now. And finally, we're going to look into the future of cloud computing. Okay, first of all, I just wanted to give you a brief about edge computing, which is going to be the future of cloud computing. So it's not cloud, edge computing is not cloud, but edge computing is like a local cloud computing network. So over here in this image, you can see cloud. We already explained over here. So this is the cloud part. So let's say this is AWS. This is the cloud computing provider. And then there comes edge. So edge nodes. So let me put it very simple here. For example, let's say you have a supermarket, and the supermarket every day it's generating 1 terabyte of data, and you want to analyze that data. So let's say you want to analyze it every single day. You want the analysis to be done every single day. In that case, when the data is generated, you're going to upload it into cloud, and then it's going to be analyzed in the cloud, and that analyzed data is going to be sent back to the local data center, the small data center which you'll be having in the store itself in the supermarket, and then you'll be using it to further analysis, right? But what if you can analyze the generated data right there in your location itself? So that basically is edge computing. You can set up a smaller analyzing system, so basically a smaller node in your local supermarket itself, which will basically speed up the process of analyzing. So as soon as your data is generated, you can basically analyze it in your own edge node, and that analyzed data would be right there in your own supermarket. So you don't have to upload or download or wait for it uploading or downloading, because obviously terabytes of data will take some time to upload, right? And yeah, so that could be done using edge computing. So service delivery, computing offload, IoT management, storage and caching. So it'll be much faster than cloud computing. So edge computing is already being implemented in various places. Even the major cloud providers like AWS, Azure, they are setting up local edge locations, and they are trying to make sure the data retrieval and the transfer of data and the services, basically it's much faster than it being on cloud. Okay, so they're already investing into it. So edge computing would be the next big thing after cloud. Okay, so the final thing is that the size of the cloud computing market. So this is according to Statista, and according to them, $146 billion is the size of the cloud computing market right now, and it is always in the increase. So it would be around $320 billion by 2025. So the size of the cloud computing market will never stop. It's going to be increasing until and unless every single company has moved to cloud, and companies are willing to move to cloud. And according to Gartner, 75% of the companies they surveyed have told that they have a cloud first approach. That is, they want to shift completely into cloud as soon as possible. So this is according to Gartner reports. Okay, and then 10.6 zettabytes cloud data center traffic. So again, so this shows that how much data has been uploaded to cloud, how much data is being analyzed in cloud. So the volume of data is going to show how big of an industry is. And if 10.6 zettabytes of data is in the global cloud data center traffic, that basically shows how massive cloud computing has grown since the first major cloud provider AWS has launched in 2006. And then 17% increased demand for public cloud services. So again, as I told you, every single company is using cloud right now, and the increase is not anything new. It is increasing every single quarter in every single year. So that is every single year, if you compare the previous quarter, there is a significant rise, about 30% every single time, in the spending in public cloud services. So this is nothing new. So basically, this is the future of cloud computing, guys. So if you are looking to learn cloud computing, this would be the right time to go for it. So you can choose any cloud provider, but AWS, Azure, and GCP are the top 3 cloud providers. After that, there is IBM Cloud, there is Ali Cloud. There are so many other cloud providers which are available, which you can choose from and start learning from. And yeah, so these 3 are the major ones. So I hope I've provided you all the basic fundamentals and all the basic information about cloud computing, where it is being used, the future of cloud computing, what are the different types of cloud computing models and services. So that's it for this particular video. Guys. I hope you all like this video, and make sure to subscribe, like, and also share the video if you really liked it. And also leave a comment down below if you have any queries, and we would be addressing them all. So thank you.